Most or all of the videos this week are going to be about NumPy, and to start out, I just want to show how to make some regular arrays, so arrays following some regular pattern using NumPy. So let's start out by importing it. Import NumPy as np. And so first array I want to make is this length 10. I mean, here I've written it like it's a list, but each time you see something like this, just imagine I want the NumPy array version of this. So I want a length 10 NumPy array of all zeros. And you'll find that there are lots of methods or functions in NumPy that are based off of MATLAB functions. So for example, there's a zeros function in MATLAB, and there's also a zeros function in NumPy. So I can say np.zeros10. And that makes this length 10 NumPy array of all zeros. Just as a little preview of list comprehension, you can make this using something called list comprehension in Python. And here's how you would do that. You have square brackets to tell Python this is going to be a list. And then I want to have 10 different zeros in here. So I put 0, and then I say for whatever, let's do underscore, for underscore in, and then I want 10 of these zeros to show up. So I'll do range 10. So there is a way to make it as a list. Okay, there are other ways too. For example, you could say, well, if you have 0 plus 0, that makes this length 2 list of 2 zeros. And so you don't want to type out plus 0 10 times. You can do times 10. That would be another way to make a length 10 list of all zeros. But personally, I prefer this way if you want a list. And I definitely prefer this way if you want a NumPy array. Okay, so that was the first example. Next, it's going to be kind of similar in the sense that it's constant, in the sense that every element inside of the array is going to be the same number. In this case, it's going to be all 4s. This is going to be a 2-dimensional array instead of a 1-dimensional array like we did up here. And so, for example, I want it to be 5 by 7. So I could do np, let's forget about the 4s for now, np.zeros, and a common mistake I make is to do 5, 7, and yet this error cannot interpret 7 as a data type. And if you check out the help for this np.zeros function, you see that the initial thing, the initial input is supposed to be a shape, and this should be an integer like what we did up here. We gave it the integer 10, or it can be a tuple. But here, it was sort of like I was trying to give it a tuple, but this isn't a tuple. I gave it 2 different integers here. And so the second integer, this 7, okay, that's showing up in the error message, that was getting set as the D type. And so that's why we got this error, type error, cannot interpret 7 as a D type. Okay, so let's come down here and say np.zeros. And now inside, I'm going to give a tuple. So tuple is with parentheses, and then I'll say 5, 7. Okay, that's good. And it's not what I wanted yet, though, because I wanted it to have all 4s. And so one way I can do that is I can say +4. And that it does what's called broadcasting. And so this 4, it gets broadcast to each of these possible slots. So all of them get a 4 added. Another way we can do it, not because it's better, but just to show you another NumPy function, is I could do np.ones, 5, 7, and then I can multiply that by 4. There's another way. If you want it to be integers inside instead of floats, well, we can use this second argument for the D type, okay, that you see here in the help. And you don't have to specify the name. You don't have to write D type. So you can just say, int here, and then times 4 on the outside. And here we get all of these different 4s. And only way you can tell it's different by looking at it is that these have the decimal point to let you know that's some sort of float. Okay, this next one, I mean, sometimes I forget that this function even exists in NumPy, even though I think it's an important one in even though I think it's an important one in MATLAB, and that is Linspace. So np.linspace, and then I'll say I want it to go from 0 up to 100, and I want it to be length 5. Okay, so here it's length 5, evenly spaced from 0 up to 100. Okay, but I don't know if we'll ever use this one again. We'll see. And okay, this one will be a little more interesting. We want this 3x3 matrix with 0 in the 0th row, 1 in the first row, and so on. So here's one way we could make this. We could say ARR for array equals np.zeros, and let's just get a 3x3 array of zeros to start. And then I could say for I in range 3, is I want this to happen 3 different times. So this will go through the 0th, the 1st, and then the 2nd. And then I can say ARR. And now I need some way to indicate that I want the 0th row. So here's how I can do that. I can just say ARR bracket 0. So in this case, I want ARR bracket I. And here I'll use this broadcasting again to say broadcast I to that. And I guess I could have done range 1 to 3 if I wanted, since I'm not changing it with zeros, but I think this is fine. So let's check. Okay, that worked. Let's go to this last one. And let me show you the first way that I would think to do this. So, or maybe the second way, but let's not worry about that for now. So again, I can make some blank, or in this case with zeros, it's going to be 2 by 5. Okay, and then I could use nested for loops. So for I, this is going to go through the rows. So for I, there are 2 rows, so in range 2. Then I'll say for j in range 5. And then I need some way of indicating that I want to go to the ith row and the jth column. The way you can do that is with ARR brackets I comma j. Okay, and then this is going to be 2. Okay, because we start out at 2 plus. And then the way I think about this is I think, how much does it go up as we move from like this column to this column? Okay, it's always going up by 3. And j is what indicates the columns, so I can do 3 times j. So let's just see what this looks like for now. I mean, if I put print ARR here, we're going to see 10 different arrays. So initially this 2 shows up, then this 2, 5 shows up, and so on. So in the end, it's basically exactly what we want, except I need to go up by 15 as we go from this row to this row. So let's fix that. So I haven't used I at all in this case. So let's say plus, and then I could say 15 times I, but I think it's a little more elegant to say, let's say columns equals 5. Okay, and then I can replace this with columns, this with columns. And then we're always going up by 3. So let's say step equals 3. And I can replace this 3 with a step. And so where does that 15 come from? It comes from having 5 columns and going up by 3 each time. So I can say plus calls times step. And then I want to only do that, or I want to like do an extra version of this each time I go to the next row. So like in the 0th row, I don't want to do anything extra. It was already correct. In the first row, I want to add 15. If there was another row, I'd want to add 30, and so on. So in general, the pattern is times I. And let's put the print outside of the nested for loop so we can just see the final version. Okay, and there is the array we wanted. So that's definitely not the easiest way to make this. Let me show you an easier way to make it. I can say np.arange. So this is the NumPy way of making ranges, and an advantage of this over the regular range that's in Python is I can have a non-integer step. I don't need that in this case since the step is 3, but if you want to have a step like 0, 0.1, 0.2, and so on, then you need to use arange, np.arange. You can't use the built-in range from Python if you want to have a non-integer step. So I want to go from 2 to 29 up by 3. And let's forget about the shape for now. And do you see what's wrong with this? Well, remember that usually in Python, the right endpoint is not included. So let's instead do 30 here. Hey, any number that is strictly bigger than 29 and less than or equal to 32 would work just as well. Okay, good. And now how do I get this into the 2x5 shape that I want? Well, there's a NumPy method called reshape. And then I can say, I want this to have this shape 2x5. Okay, and this is probably the best way to make this NumPy array, is to first use arange and then to use the reshape method to get it into the shape that we want. Okay, that's enough for this video. Thank you for watching.